Hello everyone, welcome to Fame World Educational Hub. I am Ashura Saxena, and in this session I am going to talk about document clustering using natural language processing. In this video we will explore how to group documents like news articles or product reviews using TF-IDF and K-mean clustering. We will discuss the process of text data processing, vectorization and clustering along with evaluation matrices to assess the quality of the cluster. Document clustering is the process of grouping similar documents together based on their content. In this approach, we focus on grouping news articles or product reviews based on topics or sentiments using TF-IDF, that is term frequency, inverse document frequency, for feature extraction and K-mean clustering for grouping similar documents. This technique is widely used in various applications such as grouping news articles by topics, categorizing product reviews by sentiment or features, organizing large documents dataset to improve retrieval and analysis. In building this document clustering system, we use the following key modules and techniques. Data processing, removing stop words, punctuations, and special characters from the text. Tokenization, splitting text into words or tokens. Lemmatization, converting words to their root forms. This technique converts text into numerical features, making it suitable for machine learning algorithms. K-mean clustering, this is an unsupervised machine learning algorithm using partition documents into groups or clusters. Evaluation matrix, Silhouette score, measures how similar an object is to its clusters compared to other clusters. Inertia measures the sum of squared distance from samples to their closest cluster center. For document cluster, we use a sample dataset such as the 20 news groups dataset or the Amazon product review dataset. These datasets contain textual data such as news articles or product reviews with feature like text data, like this includes the content of the document such as news articles, reviews or feedbacks, and target labels, that is optional, categories or sentiments that can be used for evaluating the clustering results. Challenges associated with this data include noisy data. Text often contain unnecessary words or special characters. Imbalanced data. Some categories or topics may be overrepresented while others may have fewer samples. Dimensionality. Text data can have a very large number of features, so dimensionality reduction techniques like PCA may be used. TF-IDF is a statistical measure that evaluates the importance of word within a document relative to collection of documents. This is calculated using two components. First one is the term frequency, that is TF, measures how often a term appears in a document. High frequency indicates that the term is important to that specific document. Formula, that is TF, T equals to number of item terms T appears in the document upon total number of terms in the document. Inverse document frequency, that is IDF, measures how important a term is across all documents in the corpus. Terms that appear in fewer documents have higher importance. Formula IDFT equals to log of total number of documents upon number of documents containing terms T. TF-IDF, the product of TF and IDF. This helps reduce the impact of frequent terms across all documents and highlights unique terms. TF-IDF term transforms the raw text numerical matrix that can be fed into machine learning algorithms like K-mean clustering. K-mean clustering is an unsupervised machine learning algorithm that groups similar data points together. It works as follows. Number 1. Choose the number of clusters K. Number 2. Randomly initialize K centroids, the center points of the clusters. Assign each document to the nearest centroid. Step 4. Recompute the centroids as the mean of all documents assigned to that centroid. Step 5. Repeat step 3 and 4 until convergence. when centroids no longer change. K-mean for document clustering. In this case, documents are assigned to clusters based on their similarity as represented by the TF-IDF matrix. Advantages like K-mean is conceptually efficient and widely used in document clustering. Disadvantages: choosing the optimal value of K can be tricky and the algorithm is sensitive to initial centroid placements. The implementation of document clustering involves several steps. Data processing: clean the text data by removing irrelevant words, stop words, and performing tokenization lemmatization. TF-IDF vectorization: convert the pre-processed text into a numerical format using TF-IDF vectorizer from scikit-learn. K-mean clustering: apply the K-mean algorithm on the TF-IDF matrix to group similar documents into clusters. The optimal number of clusters can be determined using the elbow method, which plots the inertia against different values of K and identifies the best K. Cluster analysis: after clustering, analyze the terms that represent each cluster to understand the main themes or topics. To evaluate the quality of the clusters, we use the following matrix. Silhouette score measures how well separated the clusters are. A higher Silhouette score indicates better defined clusters. Inertia measures the sum of square distances from each point to its assigned cluster center. Lower inertia means the clustering is better. Adjusting K: we experiment with different values of K and evaluate the clustering results using these metrics to find the optimal number of clusters. While document clustering using TF-IDF and K-mean is powerful, it has some limitations. High dimensionality: text data often leads to very large feature sets, which can slow down the clustering process and make it less efficient. Sparsity of data: most documents contain only a small subset of all possible words, making the TF-IDF matrix sparse. Choosing the right number of clusters. Determining the optional values of K can be difficult and may require experimentation. Cluster interpretability: it can be challenging to interpret the results of the clustering, especially when the clusters are not clearly defined. In conclusion, document clustering using TF-IDF and K-mean is effective method for grouping documents based on similarity. This technique is useful in a variety of applications such as organizing news articles and reviews. Future work could involve experimenting with more advanced modules such as latent dirichlet allocation, that is LDA, for topic modeling, or using deep learning based approaches like word to vector or BERT to improve document representation. Additionally, interactive visualizations can be developed to help users explore and understand the clusters in real time. Thank you for watching till the end. For further reading and to learn more about the techniques discussed in this video, here are some references used in this project. TF-IDF vectorization, scikit-learn documentation. K-mean clustering, scikit-learn documentation. 20 newsgroup dataset UCI machine learning repository. And latent dirichlet allocation, LDA. Thanks for watching, stay tuned and do not forget to subscribe. In case you have any queries, please put your queries in the comment section below for me to help you out in a better way. Thank you and see you in the next video.